Beginning in the early 1980s, we experimented with add-on greenhouses with large areas of sloped glazing. This created overheating in the summer that required us to vent the heat away. We also discovered that during a sunny day in the winter, very little of the sun's energy was absorbed by the surfaces in the greenhouse, and most of it ended up as hot air rising up to the ceiling. Also, on the long cold nights, cooling air flowed down off of the cold glass onto the floor. We now had temperature stratification, with the hottest air up on the ceiling, increasing the rate of heat flow through the roof insulation, and the cold air flowing down over the plants onto the floor, cooling the concrete. This does not work for the plants or for storing heat. So, we plasticized the face of the growing benches and used a ducted fan to pull the hot air off the ceiling and blow it under the growing benches. This was to put that heat into the plants and the soil on top of the benches. We then realized that we were also transferring heat to the surfaces of the concrete walls and the slab that was under the benches. We now had heat storage that moderated these day and nighttime temperature extremes. We realized that we had to actively distribute the heat into storage. Thus the birth of the air-recirculated heat storage slab concept and the title of our course, the Not So Passive Solar Construction course. The obvious material for heat storage is the concrete in your foundation. So how do we reconfigure that foundation to be able to utilize its concrete for heat storage? To begin with, you will want to replace frost walls. We can do this by using ground frost insulation. For billions of years, heat has been migrating from the core of the earth to the surface. If you replace the insulation value of the soil above the frost line with man-made insulation, you can raise the frost line to near the surface. You can now achieve this frost protection without the costly excavation, formwork, and multiple pours of concrete involved with frost walls. We have used this successfully on over 80 homes. You can now use a portion of that concrete to thicken your slab to accommodate the ductwork. It now becomes heat storage mass right where you need it, in your floor. And that concrete is totally insulated and sealed from the ground moisture and heavy gases. So, if your floor is at or near grade, you will want to extend the insulation skirt beyond the perimeter of the building. This will provide protection for lateral heat loss from underneath the building. Since few sites are level, I will look for every opportunity to earth berm the home. This can replace the insulation skirt. With earth berming, your foundation will now be losing heat to 5 degrees Celsius ground temperature instead of the minus 10 degrees Celsius air temperature in the winter. Also, it will keep you cooler in the summer. Both the ground insulation frost protection and the upcoming heat storage slab fall out of Part 9 of the Building Code and require an engineer stamp to implement. You will need to find an engineer familiar with these methods. We now introduce you to the insulated heat storage slab. This is an overview and does not include detailed drawings or all of the construction methods involved. You will find these in our one-day course for designers and builders, the Not So Passive Solar Construction course. Assuming a one-level slab, we will begin the process. Excavate with a slope to create a drainage plane for groundwater and radon gas. Trench for subgrade services. Level the clear gravel. Accurately cut to size the perimeter form. Install, square, and stake it level. Place and install subgrade service piping and conduits and have them inspected. Re-level and compact the gravel. Place extruded polystyrene SM and spray foam around service penetrations. Install vapor barrier, seal edges and penetrations, and drape over the perimeter form. Install 28 gauge metal ductwork, secure it to the SM, and plug openings with SM. Install perimeter and bury point rebar and perimeter ties. Place first load of dry air concrete to secure ductwork and floor air registers. Place remaining regular concrete, level, trowel, and finish. On the slab, lay out the foundation, exterior, and interior walls for framing. Erect with no form oil on the slab, concrete formwork, and pour. Remove forms, clean up, and you are ready to frame. Install perimeter ground frost insulation where needed. The National Building Code limits the amount of glass you can use depending on its orientation to the sun, unless you can distribute that heat. It also requires controlled ventilation in and out of your home and in and out of every living space. You have to actively recycle the air. You need to move a lot of air to move any amount of heat. The more glass, the more heat, and the more air you will need to cycle that heat into storage. As a rule of thumb, we circulate the air volume of a room or home in about 30 to 40 minutes. It helps to have a variable speed fan motor that you can tune to your situation to get just the right amount of quiet airflow. To do this, we worked with a Windsor, Nova Scotian company to develop the NewAir R500. It has a high-efficiency electronically commutated motor that allows us to accurately vary the airflow. It also has 8 kilowatt of backup electric heat built into the unit. To filter the air, we have replaced membrane filters with electronic air filters. This allows for freer airflow filtration. They are also permanent, cleanable, and use little electricity. We have been using them for over 30 years. Let us now look at how to place the air registers. To pull the hotter and more humid air off the ceiling, place the higher registers near the highest point on the ceiling, away from vertical and horizontal corners, and towards the middle of the interior wall. To intercept the cold air downflow from windows and exterior tall walls, place floor registers under them about 6 inches off the wall. This will throw a curtain of upward flowing air to intercept the cold downflowing air. Most of this high airflow is happening at the perimeter of your space, leaving the interior with a gentle airflow. Using ceiling fans will also destratify the air, but you may find yourself under its high downward flowing air in the middle of the space. This will cool you in the summer, but you do not want this in the winter. Moving and recycling the air allows you to transfer heat into and out of storage, and to destratify heat and humidity. It will also filter the incoming air and the air in the home. This will create a more comfortable, healthier interior environment. Over 90 projects and many years, we evolved the design and construction methods involved in the heat storage slab. It is a very effective way of moderating the temperature extremes in your home.